y'all. Today's objective is systems of equations. We're starting a new unit on system of equations. A system of equations, SOE, is a set of equations with the same variables. So we spent some time looking at linear functions, and we've graphed linear functions and we've solved linear functions. So now we're going to put two equations together, a set of equations. Now, the solution is an ordered pair that makes the equations true. Alright, so we're going to be finding an ordered pair that makes the equations true, and then there's three ways to solve a system of equations. The first way is graphing, the second way is substitution, and the third way is elimination. So today is just kind of an introduction to what a system is, and then we're going to take each one and we're going to go over how to graph, how to substitute, and how to use elimination. When solving a system, there are three types of solutions, and these should seem familiar because we did this earlier when we did equations. You might have one solution, but one solution with a system of equations looks like one ordered pair, and it's the intersection. You might have infinitely many solutions, and if you have infinitely many solutions, that means those are going to be the same lines, and this will make more sense when we actually graph. If you have no solution, then that means you have parallel lines because they don't ever touch. The parallel lines don't ever intersect. So you have three different types of solutions. One solution, infinitely many, and no solution. Alright, so copy this down. Determine if the coordinates are solutions to the system of equations. So example 1, here's a system of equations. There's two equations. 2x plus y equals 6, 2x minus y equals 2. So I have a set of equations, and then I have ordered pairs. Our job is to find out if these ordered pairs are solutions. And a solution makes the statement true. So what we have to do is we have to plug the solutions into the equation. So let's start with 1/8. And let's just take the first equation right here. The x is 1 and the y is 8. So we would plug it in. 2 times 1 plus 8. So see, 2x is 2 times 1 plus y is plus 8. So 2 times 1 is 2, 2 plus 8 is 10. But we need 6. So 10 does not equal 6, so that does not work. So we know it's not A. Let's try B. We're going to plug it into the first equation. 2 times 0 plus 6. So 2 times 0 plus y is 6. Because this is x and this is y. 2 times 0 is 2. 2 times 0 is 0. 0 plus 6 is 6. So that one works for the top equation, but we have to try it in the both equations. So now let's try it in the bottom equation. 2 times 0 minus y, so minus 6. 2 times 0 is 0. 0 minus 6 is negative 6. But in the bottom equation we need 2. So that does not work with both equations. Remember, it has to work in both equations, so it's not B. Now let's try C. We're going to type it into the top equation. 2 times negative 2 plus 2. See, this is your x value and this is your y value. And that equals 2 times negative 2 is negative 4. Negative 4 plus 2 is negative 2. I've copied something wrong somewhere. Okay, sorry, I'm going to make a mistake. This is not supposed to be negative. This is just supposed to say 2, 2. I apologize, 2, 2. So you erase that negative. Okay, because something wasn't working out. I knew the answer is supposed to be C. 2 times 2 is 4. 4 plus 2 is 6. And that works right here. Now let's type it into the second one. 2 times 2 minus 2, because it's minus y. 2 times 2 is 4. 4 minus 2 is 2. And then we get 2. So I C is the answer, but then I'm just going to show you why D doesn't work. So let's just type in D. 2 times negative 3 plus 0. 2 times negative 3 is negative 6, plus 0 is a negative 6, but we need a positive 6. So D doesn't work, so the answer is C. Let's do it again. Hopefully I didn't mess up. Determine if these coordinates are solutions, so we have to plug them in. Our first equation is 1/2 x plus 1. Our second equation is y equals negative 2x plus 6. So we are going to plug them in, and I remember our x, y. So for the top one, 1/2 times 0 plus 1. Notice it's this plus 1, not that. That is y. So we have to see if this equals y. 1 equals, because that's your y. Half times 0 is 0, and 1 equals 1. So that one works. Now let's try the second equation. 1 equals negative 2 times 0 plus 6. Negative 2 times 0 is 0, but does 1 equal 6? And the answer is no, so it's not A. All right, I'm going to keep showing you. Let's take B. This is your x value, this is your y value. Plug them in. So let's do the top one. 0 equals, because it's y equals, 0 equals 1/2 times 3 plus 1. Half of 3. If you don't know what half of 3 is, it's 1.5. And 1.5 plus 1, does that equal 0? 1.5 plus 1 does not equal 0, so that one cannot work. Now let's try C. Y equals, so 3 equals 1/2 times 4 plus 1. I've taken this point and I've plugged in my 3 here and my 4 here. All right, 1/4, 1/2. So half of 4 is 2, and 2 plus 1 is 3. So it works for the first equation, but we need to test it for the second equation. So I'm going to plug it in here. 3 equals negative 2 times 4 plus 6. Negative 2 times 4 is negative 8, and negative 8 plus 6. Negative 8 plus 6 is not equal to 3. Negative 8 plus 6 is negative 2, so it's not C. Now let's try D. I'm going to plug 2 into our equation. 2 equals 1/2 times 2 plus 1. See, I plugged this 2 into y and this 2 into x. Half of 2 is 1, and 1 plus 1 is 2, so it works out. Now let's plug it into the second equation. 2 equals negative 2 times 2 plus 6. Negative 2 times 2 is negative 4. Negative 4 plus 6 is 2, which is equals to 2, so that means D is our answer. All right, number 3. Y equals negative x plus 3 and y equals 2. Here is your system of equations. And is 1, 2 a solution? So we need to plug it in. So we plug in 2 here and 1 here, because this is your x value and this is your y value. Negative 1 plus 3 is 2, so it works for here. Now we need to plug it in here. So this is your y is 2. There's no x, so I don't plug anything in, and is 2 equal to 2? Yes. So the answer is yes, it is a solution. Now all of these I showed you just had one solution, one ordered pair that makes both sentences true. Now, just for helpful hints, sometimes it's helpful if you make a table. So I'm going to show you with this equation how to make a table. We've made tables before, negative 2 through 2, and I have 2 equations. We're going to say this equation is A and this equation is B. So if I put in negative 2 right here, negative 2 times negative 2 is 4. 4 plus 6 is 10. Now I'm going to type in negative 1. Negative 2 times negative 1 is 2. 2 plus 6 is 8. I'm going to put in a 0. Negative 2 times 0 is 0. 0 plus 6 is 6. And maybe you see the pattern. 10, 8, 6, and then 4, and then 2. So that's nothing new. You're just plugging in the numbers, and then you are getting your y values. Now let's do equation B. Negative 2 right here. Alright, so if I plug in negative 2 right here, this is going to be 2 times negative 2 plus y equals 6. This this is -4 plus y equals 6. So I have to figure out what can I put in right here for y to get a positive 6. So you have to solve this equation by adding 4 to both sides, and we get y equals 10. All right, so now let's do it with -1. We're going to type in 2 times -1 plus y equals 6. I'm just using this second equation. 2 times -1 is -2 plus y equals 6. Then you're going to add 2 to both sides, and you get y equals 8. Now, do you see something happening? If we plugged in 0, we would get 6. If we plugged in 1, we would get 4. And if we plugged in 2, we would get 2. Now, you should see something happening with these table of values, and you should see that all of the values are the same. This would be an example of infinitely many solutions, because we could keep going and all of those solutions are going to be the same. So if you notice that all of the coordinates are the same, then you know it's going to be infinitely many. We're going to practice more solving by graphing in class, and I'll see you later.